Good morning, students. The next topic of first chapter is equilibrium of bodies. The term equilibrium denotes the state of a body. If a body continues in the same state of rest or motion, even though a number of forces are acting on it, then we say that body is in equilibrium. Means a body at rest continues in the same state of rest even though a number of forces are acting on it. Similarly, a body which is making uniform motion. Uniform motion means it moves with a steady speed along a straight line. It continues the motion without any change in the speed or direction even though a number of forces are acting on it. This state we call as equilibrium. Equilibrium is of two types, static equilibrium and dynamic equilibrium. Static, the word static means rest, stationary. So static equilibrium means a body at rest continues in the same state of rest even though a number of forces are acting on it. Let us see some example. A book kept on the table. On this book, there are two forces acting. One is its weight, which acts downward. The other one is the normal reaction force exerted by the table on the book in upward direction. So, on the book, there are two forces acting. Still, the book remains in the same state of rest. The reason is that the sum of these two forces is 0. If weight is 100 Newton, the normal reaction is also 100 Newton. Since direction is opposite, their sign is opposite. Means if the weight is positive 100 Newton, the normal reaction is minus 100 Newton. So when we take the sum of the linear forces, it is 0. This is one condition for a body to have equilibrium. The sum of linear forces must be 0. Then next one is dynamic equilibrium. It is dynamic means moving. A moving body continues the uniform motion even though a number of forces are acting on it. That is known as dynamic equilibrium. Consider a car moving along a straight road. Suppose the car moves in this direction. That means the force of engine is in this direction. There are many other forces acting on this car. The weight of the car acts downward. Normal reaction of the rod in upward direction. And the frictional force of the rod as well as air acts in opposite direction of motion. If the sum of all these forces is 0, the car will continue the uniform motion. Means the car will go with the same speed in same straight line if the net force is 0. If the car has to increase the speed or decrease the speed or change the direction, there should be some change made in the force of the engine. Accordingly, it can change, means the net force will not be 0, it will be unbalanced and the state of motion, uniform motion will get changed. So, a body continues the uniform motion along a straight line even though a number of forces are acting on it. That is known as dynamic equilibrium. Dynamic equilibrium is of different types: translational equilibrium, rotational equilibrium, like that different varieties are there. Next topic, principle of moments. This principle states that when a number of forces act on a body and the body still continues in rotational equilibrium, that means the sum of clockwise and anti-clockwise moment is 0. Okay, I will give one example to make the point clear. Imagine a rod is suspended horizontally by hanging with a thread from its midpoint. A rod is suspended freely. AB is the rod. Okay, it is hanging from a fixed point. Now you can see the rod remains horizontal. If I am hanging a weight on the left side, naturally this rod will tilt or rotate in anti-clockwise direction. Or you can say some anti-clockwise moment will be produced. Suppose the weight hanging here is 100 Newton and this distance is 1 meter. So how much is the anti-clockwise moment? Moment is force into momentum. Force is 100 Newton, moment arm is 1 meter. Distance from the pivoted point to the line of action of force. So it is 1 meter. So anti-clockwise moment is equal to force into momentum. 100 into 100 Newton meter is the anti-clockwise moment, and the scale, this rod will remain. If this was the rod which was remaining straight earlier, now it will turn anti-clockwise. It will not balance. Now what I am going to do is, another weight I am suspending on this side at a distance of 0.5 meter. At a distance of 0.5 meter, I am hanging a weight of 200 Newton. And this 200 Newton force, it will produce clockwise moment. That clockwise moment is 200 into 0.5. Force into momentum. We will get it as 100 Newton meter. So in this situation you can see the scale will again get balanced. Earlier when there was no weight, scale was remaining, the rod was remaining horizontal. When this weight 100 Newton was attached, the scale got turned in anti-clockwise direction. Now when the second weight 200 Newton was attached on the other side, this force produces clockwise moment, thereby the scale comes or the rod comes in horizontal position or equilibrium, because the clockwise moment and anti-clockwise moment is magnitude is same. Direction is opposite but magnitude is same. So what in this case, the how the rod was remaining earlier when there was no weights hanging, the same way this rod remains after hanging two weights. So we can say it is in rotational equilibrium. The rod was remaining straight when there were no weights hanging. When this 100 Newton weight was suspended, the rod got tilted in anti-clockwise direction, or it got anti-clockwise moment. And this force 200 Newton or weight 200 Newton produces clockwise moment. Though there are two moments acting on the body is not getting tilted or getting rotated either clockwise or anti-clockwise. The reason is that the clockwise and anti-clockwise moments are equal. So the rod remains as it was earlier. That situation we call as rotational equilibrium. Though there are two forces which can produce rotation on a body, in effect there is no rotation happens. That situation is called rotational equilibrium. And the reason for that is the sum of these two moments is zero. You know, anti-clockwise moment is given positive sign, clockwise moment is given negative sign. So when you take the algebraic sum of anti-clockwise and clockwise moment, it goes as zero. So you can conclude that a body will be in rotational equilibrium only if the sum of clockwise and anti-clockwise moment is zero. or we can say the numerical value of clockwise and anti-clockwise moment are equal. Only numerical value, sign is opposite. So this principle is known as principle of moments. We can prove principle of moments with an experiment, laboratory experiment. Look at the diagram. Hang a meter scale, uniform meter scale from its midpoint. It remains horizontal. Now get two similar spring balances and attach one spring balance on the left side at certain distance d1. Attach a spring balance together with a pan on the left side at a distance d1 and keep some weight in this pan. Then the scale will turn anti-clockwise. Scale will turn, rotate anti-clockwise. Now as the next step, attach the second spring balance on the right side at certain distance d2 and keep some weights in it so that the scale remains horizontal. You have to add the weights in it. Distances must be different and the weight you have to add in the second pan so that the scale comes in horizontal position. Suppose the weights kept here are W1 and W2. This weight W1 produces anti-clockwise moment and the weight W2 produces clockwise moment. After balancing the scale, you just measure the readings. Measure the distance D1 from the scale and D2. Find out how much is the weight on the two pans W1 and W2. Now you can, if you know these four readings, you can calculate what is the anti-clockwise moment, that is W1 into D1, and the clockwise moment is W2 into D2. And when you do the calculation, you will see that numerical value of these two are same. Okay, so when you take the algebraic sum, it becomes 0. So this experiment proves principle of moments.